Right, welcome back. So what I've decided to do is use the maximum percentage uncertainty I had for any particular value of depth in my time. So in this case it was this one here, 0.025 as a fraction of 0.93, and I've used that to apply that to all my velocities or wave speeds. So here in the working out the percentage uncertainties or the fractional uncertainties and adding them, I've used the values here for each value v. Okay, that has a consequence of making all these the same, and it also makes them larger. So you can see that now my graph, we've got a better chance of fitting maximum and minimum lines without having to go away and do some more data gathering, or without having to sort of take points out. Really, the purpose of this is to show you what I'm going to do next. Now, maximum line. So I've got a line, I can find the gradient of it. That's all well and good. I might as well write the gradient down. So I'll write it over here, 0.4676, just so I have an idea of what it is. Okay, I'm going to now get rid of that equation, just to clear space, and I'm going to think about, right, how can I add another line on this to act as a maximum line? Now, I usually go from, use 2 points as a starting point. I want to go from the top right of this error box here to probably the bottom right of this one here. Okay, you'll see what I'm going to do in a minute. So, what I do, I type in somewhere on the chart max x, y. So I need 2 points with which to proceed. Let's do this one first. So the bottom right hand corner of this error box, right, the box formed by these two error bars, is going to have an x coordinate of minus 0.5 plus the absolute uncertainty in log of d, which is 0.167, and it's going to have a y coordinate of 4.0, which is the value of log of v at that point, minus the absolute uncertainty of log of v, which is plus 0.038. Be careful. So this point up here is going to have an x coordinate of 1.4 plus 0.026, no thank you Windows, and this point is going to have a y coordinate 4.9 plus the absolute uncertainty, again in log of v, 0.038. Okay, I'm now going to plot this line. The easiest way to do it, or to add it to the chart, I find, is to right click on the chart, click on select data. I'm then going to, you can see there's data here already, that's the data I've already got in. I'm going to add a new set of data. And I'm going to call the series name maximum, and the series x values are going to be those, the series y values are going to be these. If I click OK, you can see that so the x value here is 1.066. It should be, of course, 1.4, because that's the x coordinate at this point here. That's more like it. Now, if I plot a trend line, number 1, and then get rid of these points because I don't like them, format data series, marker options, none, I now have a line which I can vary somewhat. Okay, now at the moment, again, this point here is not starting in the right place. I want this to be starting down here at 4.0 minus 0.038. Okay, something like that. Okay, that'll be quite useful, as you'll see. So it's interesting where it's starting, but nevertheless, let's run with it. So I'm going to now talk about the tab. So if I click off the chart, now under normal circumstances, you will find that your ribbon looks like this. So you'll have a home, insert, page layout, formulas review, data, and view. You can add a hidden tab by clicking on File, Options, clicking on Customize Ribbon and going to this right hand side. You can see that you've got the ones which you're familiar with. There is an extra one, Developer, which you can check, click OK, it suddenly appears. It's got a number of useful functions which I'm not going to go into, but the one I'm interested in is the following. So Insert, Controls, I'm going to choose this one here, Spin button. You can see that my cursor's pointed into a cross. If I drag, I can create one of these form controls. If I click off it and then click back on it, you can see that those two buttons act independently. I'm now going to right click on it and click Format Control. I need to link it to a cell, so I can do this by clicking there and selecting the cell I want to link it to. Current value can be 0, minimum value 0, maximum value 30,000, and what I'm going to do is I'm going to make this control change the value of that cell incrementally when I click on it, like that. Okay, so you can rewind if you want to see how to do that. Again, I'll be doing it again in a minute. Now, why do that? I want to be able to move this point here to the left. Okay, you'll see why in a minute. So I want to be able to take off it. So if I click on this and change the formula minus this value divided by 50. Now I'm doing that just so I don't change by one every time when I click this button. I want to have finer control. So if I just do this for a minute, I want you to watch what happens to this line as I click on this form controller. Okay, so you can see that I can change its position now using that control. Beautiful. So I'm going to do the same thing again, only this time I'm going to be changing the x coordinate of the point up here. Again, Format Control, link it to that cell, click OK because all these are fine. Current value 0, maximum and minimum, incremental change. The incremental change can't be, unfortunately, less than 0, so that's why I'm having to go with the divide by 50. You can see that this increments that box. Divide by 50 in for instance this formula here, okay, to sort of regulate the change. Now I want to be able to move this point in the top right hand corner to the left, so again I want to take off the value in there divided by 50. You can see that if I do that, I can vary this line to go through the error bars as I want. Now I want this to have a maximum gradient. Now as long as it stays within the squares formed by the error bars, we're good. So that's what I'm going to do. I'm going to try and adjust it so I have a maximum gradient while going through all the error bars. Okay, so I'm looking carefully here. So again, we're looking at this line, going through them all. Now I'm pretty much reaching the end. If I go one more, it's still just about within that error bar. So that's as far as I'm going to go. So that's the line there. So I'm going to leave that as it is. I'm now going to add another line, min, with x and y values. So this time I'm going to start it up here the top left hand corner of this point. So I'm going to go x value minus 0 equals minus 0.5, and I want to add to 0.5 the absolute uncertainty 0.167. The y value is going to be 4 point. Do I want to do that? I want to subtract 0.167. For the y coordinate, I want to go 4.0 and then add 0.038. Okay, we can make adjustments to this in a minute. For this cell, the point of the minimum line up here, I want to go from the top, something like to the bottom right. So we'll go for x value 1.4 plus the absolute uncertainty 0.026, and for the y coordinate I'm going to go with 4.9 minus 0.038. So I'm just taking off the absolute uncertainty to get down to here. If I add this to the chart, so I'm going to select data again, add. The computer's being very slow now. Series name, minimum, and x values as so, y values, and then click OK, and OK again. You can see that I've now got two green triangles. I'm going to this point here, I'm going to shift up a little bit, so the y coordinate needs to be moved up. Let's try 0.06. That'll do. Even a bit more, 0.07, and I'm going to again use these controls to, so insert form control, to give me some control over these values. So I'm going to just do the two at once. This one I'm going to assign to this cell, and this one I'm going to assign to this cell. Click OK. So you can see that this one is incrementing that cell, this one is incrementing that cell. I want to be able to change this point and bring it further down. So I want to be able to adjust it in that sort of sense. So I want to be able to change the y coordinate, make it less. So I'm going to go y coordinate and subtract the value in that cell divided by 50. Again, we can make modifications as and when we see fit. I can test it. That's going to bring it down. And then this one I want to be able to bring up. So I'm going to click on that and then add the value in that cell divided by 50. Right. So, if I add a trend line, as before, and again delete these green triangles just because I don't like them. There we go. I've got a minimum line now, potentially what is a minimum line, which I can adjust using these controls. Now I want the minimum possible gradient. So as long as they go through, again, the squares formed by the error bars, that's fine. It's missing this one drastically. If I bring it down like this, yeah, it's not going to work. So I'm going to need to adjust this. So I'm going to bring this down as far as I can, or bring this point up as far as I can. So it's going through the square formed by this error bar, that error bar, this error bar, all the way down. Now I'm going to adjust this, bring this point down to see how far I can get. At the moment I'm missing this one, so I want to bring it down so that I'm hitting this. And I'm actually now going through all of them. So I'm going to leave it at that. I want you to watch what I'm going to do now. So my actual gradient was 0.4676. 0.4676. In fact, I'm going to bring this over here. So actual 0. What was it? I've forgotten already. That's not good. Okay, so let's go back from this. So the actual trend line, I'm having difficulty selecting it now. So the actual trend line, display the equation, 0.4676. 0.4676. The maximum line I've plotted, if I display its equation, it's 0.5366. 0.5366, and the minimum line is going to be 0.4548. 0.4548. Now, why is this useful? Well, it is one method by which you can get some idea of the uncertainty on your gradient. So, if my gradient to two significant figures is 0.4647 even, yes, that's close to 0.5, but now I can actually use quantifiable, some quantities to get some idea of whether it's acceptable given my experimental uncertainty. Now I'm going to do something similar here as I did before. I'm going to take this value and subtract it from the minimum gradient and then divide the whole thing by 2 to get an absolute uncertainty, or some idea of the absolute uncertainty on the gradient. Okay, 0.24. Can you see what I've done? There we go, 0.04. Okay, now to two significant figures, that's 0.04. So I would now be able to argue, better than I could before, that my gradient is now 0.47 plus or minus 0.04. Okay, now given that my and if you ever want to use a plus or minus symbol, if you go to basic Latin, you should be able to find, or perhaps Latin supplement. Here we go, you should be able to find the plus or minus symbol. I'm going to insert that in front of the 0.04. So you can see if I say now my gradient's 0.47 plus or minus 0.04, my error bars actually allow me to state that my gradient as found, right, agrees with the theory, right, because the theory suggests that the relationship between depth and wave speed should be a square root, so to the power half. And 0.5 lies within experimental uncertainty, right, of my value. Okay, so that's a much more satisfying way of doing a data analysis, using maximum lines, using these developer controls to adjust the maximum minimum lines. Okay, hopefully that gives you some sense of some of the things you can do with Excel which you possibly weren't aware of. I will endeavour to make a more formal tutorial at some point, but I hope that helps you for now.